So in this experiment we're going to work out the formula of magnesium oxide. We're going to take some magnesium and we're going to roast it in air to form magnesium oxide, and then by taking the mass of the magnesium to start with and the magnesium oxide that we form, we'll be able to calculate the formula of magnesium oxide. Okay, so the first thing I'm going to do, I'm going to heat it inside these bottle tops held together by nichrome wire. So I'm going to take the mass of the two bottle tops that I'm using and the nichrome wire, and that is a mass of 5.196 grams. So I'll take a note of that. And now I've got approximately 15 centimetres length of magnesium ribbon that I've wrapped into a tight circle. Okay, and I'm going to take that and put it inside my bottle top. Okay, and I'm going to wrap the nichrome wire around the bottle top to hold them closed together. Okay, so I can get them there, wrap them around, and that should hold the bottle tops tightly closed. So I'm going to weigh the magnesium ribbon that is now inside the two bottle tops held together by the nichrome wire, and that is 5.868 grams. Okay. So now we're going to heat this. Okay, this is acting as a little crucible. We're going to heat this with a Bunsen flame, full open air hole, blue flame, for approximately 5 minutes. Okay, so if we turn on the Bunsen like that, and then we're putting it onto a blue flame, and we'll heat it for approximately 5 minutes. And we should see the magnesium light as it reacts with the oxygen in the air. We'll possibly see the glow through the bottle tops. It probably will go bright at some point as the magnesium catches fire. So we'll now turn the Bunsen burner off and we'll allow that to cool for a few minutes. If we now transfer the bottle tops and reweigh them, the mass is now 6.332 grams. To actually calculate the formula of magnesium oxide, we use these three masses that we have taken. Okay, so I can work out the mass of magnesium that was in the bottle tops by simply taking M2 and subtracting M1. Okay, so the mass of magnesium equals M2 minus M1 equals 5.868 grams minus 5.196 grams, and I've got a calculator at the side here. I can do that, and that is 0.672 grams. Okay, now I can work out the mass of oxygen that has bonded onto my magnesium by taking M3 and subtracting M2, okay, because M3 was the bottle tops plus the wire plus the magnesium oxide compound, and M2 was the bottle tops and the nichrome wire and just the magnesium. So this difference in mass here is from the oxygen. So the mass of oxygen is equal to M3 minus M2 equals 6.332 grams minus 5.868 grams, and that comes to 0.464 grams. Okay, now my next step is to work out the number of moles of the magnesium and the number of moles of oxygen, because it's that ratio of the number of moles that will tell me the formula of magnesium oxide. Okay, now I can use the formula that we have used before, that to work out the number of moles for magnesium, it is just the mass divided by the GFM, the gram formula mass, which I can get for from the data booklet. Okay, so the mass of magnesium that I had is 0.672,
And if I look at the data booklet, I find that the relative formula mass of magnesium is 24.5. Okay, so if I plug that into my calculator, I find I have got 0.027 moles of magnesium. Okay, now I want to work out how many moles of oxygen I have. So I can use the exact same calculation, the mass divided by the gram formula mass, or the relative formula mass of oxygen, since we're working with an element, and the mass was 0.464. And if I look at the data booklet, I find that the relative formula mass of oxygen is 16. Okay, so if I plug those numbers into the calculator, I find I have got 0.029 moles of oxygen. Okay, so my final step then is to work out the simplest mole ratio. So the mole ratio, if I work out the magnesium to oxygen mole ratio, it is 0.027 to 0.029. Okay, now to find the simplest mole ratio, I want to divide by the smallest. Okay, so the smallest out of those two numbers is the 0.027. So 0.027 divided by 0.027 is going to be 1. And if I put 0.029 divided by 0.027 into my calculator, it comes out at 1.07. So we can round that down to 1. So it's pretty much a 1-to-1 mole ratio, which means that the formula of magnesium oxide is MgO. I have 1 mole of magnesium atoms bonding on to 1 mole of oxygen atoms.
So from that we can work out the mass of oxygen that has bonded onto the magnesium, and that allows us to work out the formula of the magnesium oxide.